let us learn about the polynomial, value of polynomial. What do you mean by value of polynomial? If k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equals to k and is denoted by p of k. What exactly did we understand from this? Yes. See, let's go with this. First of all, we understand the question here. If k is any real number, then value obtained by replacing x by k in p of x is known as value of p of x at x is equals to k. For this, let us go ahead with an example. Here we have the value of p of x. What do you mean by p of x? It's nothing but name given to a polynomial. P stands for polynomial and x denotes that the variables used are x in the polynomial at x is equals to minus 1. So they are asking us to substitute the value of x as minus 1. Here p of minus 1, instead of x we have substituted minus 1, and here x square where we have written minus 1 the square, and 3x we have written 3 into minus 1 and 4. So I mean to tell you that instead of x we have replaced it by minus 1. Done. What's the next step? As we know, minus 1 square we're gonna write 1, and minus into minus we're gonna write plus 3, that is 3 into 1, and minus 4 as it is. It's here. Minus into minus we have plus, and 3 into 1 we have 3, and minus 4 as it is. Now if you have really understood this, the next step I hope you will be solving it as 4 plus 4, 4 minus 4, 1 plus 3, it's 4, and here it's minus 4. Obviously it's gonna be 0. So here minus 1, p of minus 1, I've just brought it down, and here the value is 0. So here instead of x we have substituted the value as minus 1, and we are getting 0 as our value. This is known as value of the polynomial, that is p of x equals 0, which means the value of the polynomial, given polynomial p of x is 0. I hope you understood. Yes, at x is equals to minus 1. The next example, the value of p of x. Once again, p of x, the name of the polynomial with the variable x. So we have the polynomial at x is equals to 1. So they're asking us to substitute the value of x as 1. Wherever x in the given polynomial, you substitute it as 1. So 1 square minus 3 into 1 minus 4, it just goes like this. 1 square is 1, and 3 into 1, it's again 3 and negative sign as it is, and minus 4. So it's gonna be 1 minus 7, which is nothing but minus 6. I hope you understood. Yes. So it's the value of p of x is minus 6 in this case. Yes, I hope you understood. At x is equals to 1. Yes, now let us learn about finding the number of zeros for the given graph. Okay, here in this, look at the graph given below. Each graph is of y is equals to p of x, where p of x is a polynomial. For each of the graph, find number of zeros. As we know, when we say number of zeros, the number of times the graph is touching the x-axis. So here it is touching once. Yeah, it is only once. So number of zeros equals 1. Come to the next part. In this graph, how many times is that touching? It's touching 1, yes, 2 times. So the number of zeros equals 2. And the third graph, we have once, twice, and yes, thrice. Great. Then so number of zeros equals 3. Coming to the next graph, yes, it is touching at 2 points, but number of zeros means number of times touching the x-axis. You have only one x-axis and it's touching only one time. So number of zeros equals 1. And in this case, yes, the curve is coming down, and once it touches, it's going up. So it's again one time. Number of zeros equals 1 time. The next question, here it's touching once, twice, thrice, and here 4 times. Okay, the number of zeros in this case is 4. Yeah, we have some more questions here related to the same like number of zeros. Yes, number of zeros in this case is 0 because the line is never, not touching the x-axis, and it will never touch the x-axis. And yes, and in this case it is touching once. Great. Okay, next we'll go with 1 time. And yeah, the third question we have I believe it's 3 times. 1, 2, and 3 times. And here number of zeros 3. In this case you're right, it's 2 times. In this case 1, 2, 3, and yeah, 4. Yes, number of zeros equals 4 in this case. It's like 1, 2, and 3. Yes, number of zeros equals 3. Come to the next point. Let us learn about the relation between the zeros and its coefficients. What do you mean by zeros and coefficient? Once we solve this quadratic equation, we're gonna get 2 answers. It's like this. I have split 9 as 5 and 4. I hope you know the factorization. If in case if you have any doubt in factorization, comment. We will solve. Okay, once we have done with factorization, as we know, okay, let me finish it. 2 into 10, it's 20. And what do I have in the middle is 9. As we know, if I multiply any 2 numbers, that is integers, I need to get 20. In this case, if I add the same 2 integers, I need to get 9. So in this case, it's none other than 4 into 5. So for 5s are 20. At the same time, 4 plus 5, which is equals to 9. Yes, I hope you understood. Okay, so the reason we have 5 and 4 here, and 2x square can be written as 2 into x into x. 5 can be written as 5 into x. So how about 4? Yeah, it's like 2 into x. Okay, and 10, it's like 2 into 5. Then so we group 2 numbers, 2 terms, that is for the 2x square and the 5x and the 5x. Once we take these 2 over here, and these 2 is being expanded here. Okay, see, this expansion is not required in the examination. You need not write it in your answer sheet, but it's to our reference so that we understand better. See, here x is there and here 1x. That is, I mean to tell you, after the plus sign, and this sign it is before the plus sign. So after the plus sign, before the plus sign, this is after the plus sign and this is before the plus sign. What do we have in common is x. So let me write x, and what is left? 2 into x, that is 2x over here, and here it's 5. Yes, so now 2 into x and 2 into 5. See, 2 is in common. If 2 is in common, we write 2, and what is remaining? This 2x and 5 is remaining. We have mentioned over here. Yes, I hope you understood this. And coming to the next, 2x plus 5, this is after the plus sign and before the plus sign. We have 2x plus 5 in common. So we write 2x plus 5, and what is left? If this has been taken out, what is left is x and 2. So we write it over here, x plus 2. Okay, fine. So now 2x plus 5, and here it is x plus 2. We call these two as factors. We call it as factors of the polynomial. Factors, yes. So these two are known as factors of the polynomial 2x square plus 9x plus 10. Yes. So once we are done with this, now let us take this alone and equate it to 0. Let us assume that 2x plus 5 is equals to 0. Then what happens here is, 2x is equals to minus 5. Then the value of x will be minus 5 by 2. Yes, and in this case it's x is equals to, if I say okay, in this case if I say x plus 2 equals 0, then x is equals to minus 2. See, in the other case I had minus 5 divided by 2. See, the easiest way to get this is, here we have, take x, it's plus 5, we mention it to be minus 5, and here we have 2x, right? So 1x is here, where's the 2 divided by 2, and here plus 2, the other side we write it as minus 2. I hope you understood, and we have noted the same thing here. Okay, fine. These are called as 0 of the polynomials, as we know. We call this as 0 of the polynomial. What's the reason? In case in the given equation, if in case we substitute the values as minus 2 or minus 5 by 2, we're gonna get 0 as our answer. And since we have two values for x, we mention it to be alpha. Okay, let me first come out with this. I have noted the same over here, and x minus 2. Now we'll go with, see, relation between zeros. Here we have something called sum of zeros. Sum of zeros is nothing but adding these two, that is x and x. Okay, fine. Okay, here we cannot add, as this is a fraction and this is a integer. So I take denominator to be 1, and take this 2, multiply up and down. Okay, up and down, and then take this 1 and we multiply it here, because 1 into anything is the same thing, we neglect it. Then 5 into minus 1 is minus 5, 2 into 2 it's 4, and minus over here. So it's minus 5 and minus 4, we're gonna get minus 9 divided by 2. Okay, this is nothing but sum of the zeros. Yes. Coming to the next part, we'll go with product of zeros. Product of zeros, let me say, x, that is minus 5 by 2 into minus 2. When you multiply, see, minus into minus, it's gonna be plus. 5 into 2, it's gonna be 10. 10 divided by 2. Okay. See the fun over here in your, what do you call it as is, okay, let us consider the given polynomial and write the standard form of it. So in the place of a, we have 2 here. In the place of 9, we have b. In the place of c, we have 10. What I mean to tell is, a equals to, when I compare the standard form with the given polynomial, a equals 2, and b equals 9, and c equals 10, and c equals 10. Yes, so a equals 2, b equals 9, c equals 10. And check over here what we have in the sum of zeros column. We have 9 by 2. It's nothing but b divided by 2, but 2 is nothing but a, I mean to tell you. Okay, here 9 by 2, and we have a negative symbol, so shall I write minus b by a? Yes. Coming to the product side, you just say it is 10 by 2. 10 is nothing but c, if you can see here. 10 is nothing but c, and the value of a is nothing, 2 is nothing but its value of a. So what I mean to tell you is, it's minus b by a, and here it is c by a. So sum of zeros, the relation, if it is sum of zeros, then coefficient of the x divided by coefficient of x square, and in this case product of zeros, it is coefficient of c, that is constant, divided by coefficient of x square. I hope you understood. Yes, as you know, if there is any doubt, comment, we will get back to you. Okay, done. Coming to the next question, find the zeros of the quadratic polynomial. As we know, if the highest degree is 2, we call it as quadratic, and we have x square plus 7x plus 10, and verify the relationship between the zeros and the coefficient. It's the same question again. Okay, let us try to factorize it. It's 5 and 2. The reason, when you multiply, it should be equal to the third number. When you add, it should be equal to the middle number. Yes. Okay, then we have grouped it. And we have x square can be written as x into x, 5x. Then okay, and let me do that later. Here we mention it as 2x and 2 into 5. Then grouping these 2. Here I have taken x as common, and we have x5, which is not common and left out thing. Yes, and here we take 2 and 2 as common. So what is left is x and 5 with the plus sign. I hope you understood. Coming to the next part, in these two, x plus 5 is common again, and what is left is x, and over here 2, so we write x plus 2. Then as I told you, x here it's plus 5, so we say x equals minus 5, and here it's x plus 2, we say x equals minus 2. So these two are the zeros of the polynomial. Yes, so once you have the zeros of the polynomial, I mention it as alpha. This is not a, this is alpha. Okay, and here we have beta. Alpha is equals to minus 5 and beta equals minus 2. That is, we have two values, so I have given names to both the values, or else here we will have a confusion. X is equals to minus 5 and x is again minus 2. So there are two values. First value is minus 5 and the second value is minus 2. I hope you understand. If I'm too fast, you comment to reduce my speed. Yes. So now coming to the next part, sum of the we are comparing it with the standard form, that is ax square plus bx plus c. Instead of a we have 1, in the place of b we have 7, in the place of c we have 10. Okay, then sum of zeros. Yes, sum of the zeros, it's over here, and let us write product of zeros too. Product of zeros like c by a. Yes, okay, then sum of zeros we say alpha plus beta, because x value and x value, I mean to tell you, is equals to minus b by a. Yes, now here see, if it is sum we are writing plus in between, and if it's product we are writing a multiplication symbol in between, is equals to c by a. I hope you understood. And coming to the next part, I'm substituting the value of alpha. Over here, and over here the beta, and equal sign as it is. In the place of b I have 7. As I told you, b I have 7, and divided by a. In the place of a, if x square is cancelled, there is no number, we consider it to be 1. Then see, it's plus into minus is minus, so minus 5. Okay, fine. Here we have product first. Alpha, that is minus 5, into beta is negative 2. Then the value of c is 10 over here, and let's substitute it the sign, divided by, we have a value as 1, and coming to this end, yeah, minus, okay, this plus into minus is minus, it's minus 2, and here it's minus 5, so it's gonna be minus 7. This end, minus 7 divided by 1, it's gonna be again minus 7. LHS and RHS are equal in this case. Coming to the product, minus into minus, it's gonna be plus 5 2s are 10, equals 10 divided by 1, it's gonna be 10. So here the products are equal, the sum is also equal. This sum, by practically finding the value and cross checking it, this is from the coefficient rule, that is sum of zeros will always be equal to the middle number, negative of the middle number divided by the first number, that is coefficient of x squared. I hope you are clear with this. Yes, and this is very much important for your examination. You will get a question. Yeah, the very next question is, find the zeros of the polynomial x square minus 3 and verify the relationship. Okay, in this case they have asked us to find the zero of the polynomial. Let me note down the polynomial first. Yes, x square minus 3. once we have done, see in this case we have nothing to take in common, and it is not a trinomial to split the middle one, and there is no other go. We need to use one or the other formula. See, the first one is in square, so you know the formula with first one square and negative sign is something like this: a square minus b square. But again, it is b square, where second part is not in the form of square. We will have to get it down or derive it, write it in the form of square. So what can we do here? We have root 3 the whole square. See, if it is root 3 the whole square, we have two things to be considered. 3 square is nothing but 9. What is root of 9? It's again 3. So 3 can also be written as root 3 the whole square. I hope you understood this. It is in the form of, here we go, it is in the form of a square minus b square, where we have a minus b into a plus b. A square minus b square, we have a minus b into a plus b. So the question is x square minus root 3 square, where we can write x minus root 3 and x plus root 3. I hope you understood. Yes, in this case, see, x minus root 3, then x is equals to root 3. Your x plus root 3, then x is equals to minus root 3. Yes, you're right. So these two are known as zeros. So I mention it as alpha, the first value, beta, the second value. Then they have asked us to find the relation. So verify it. That is, I'm writing it in the standard form. See, standard form is ax square plus bx plus c. What do you mean by c? Without any variable. Yes. So the whole thing is c. What is a? The value of it is coefficient of x square. Next to x square, what do we have is nothing, so we consider it to be 1. Then how about b? Nothing is here, so we consider the value of b to be 0. Okay, now sum of the zeros. What is the formula? Yeah, right. Minus b by a. Shall we substitute the values? And your product of zeros, c by a, coming to the sum. Alpha plus beta is equal to minus b by a. Then what do you mean by product? Yes, multiply alpha into beta is equal to c by a. Then what's the value of alpha? What's the value of beta? And here equals minus b by a. So minus 0 by 1. Why is that b 0? Because they haven't mentioned any number as the coefficient of x. There is no x, to be frank. Okay, so we consider the coefficient to be 0. And here plus into minus, it's gonna be minus. Okay, fine. Let us come here for the product thing. Alpha is root 3 and beta is minus root 3 is equals to c. The value of c is 3 over here divided by a. That is 1. And yeah, as I told you, plus into minus, it's minus, is equals to 0. 0 divided by any number, it's gonna be 0. And root 3 minus root 3. Okay, before that, let me come to the product form. Root 3 into root 3, it's gonna be minus root 9 is equals to minus 3. Then coming to your sum of zeros column, root 3 minus root 3, it's gonna be 0, which is equals to 0. And other end, minus as it is, root of 9, what is root of 9? 3 is equals to minus 3. Okay, I hope you understood. So it's verified. Okay, thank you for viewing this. If there is any doubt, please try to comment and contact for one-on-one tuition. We will go ahead with even online classes. Thank you.